This drop of ocean water is about to disappear from sunlight. If its journey follows the great overturning circulation, it may not return to the surface for centuries. So Pip has marked it with a tiny golden glow. Let us follow it. At first, nothing looks unusual. The drop floats in warm Atlantic water beneath a bright tropical sky. But the ocean is never still. Wind drags across the surface, Earth turns beneath it, and entire rivers of seawater begin to curve around the planet. Our drop is swept into a warm surface current. It does not race through a narrow tube. It drifts inside a moving mass of water, nudged by wind, neighboring currents, and the shapes of continents. Northward, it travels with water connected to the Gulf Stream and the North Atlantic Current. This flow carries far more than water. It carries tropical heat toward colder latitudes, quietly moving energy from one part of Earth to another. Near the far North Atlantic, winter changes everything. Cold air pulls heat from the sea. The glowing parcel cools, the molecules move a little closer together, and the water becomes denser. Sea ice can make it denser still. When seawater freezes, most of its salt is pushed out of the new ice. The ice becomes relatively fresh, while the liquid water around it grows saltier. Cold water is dense, salty water is dense. Combine both, mix them with the surrounding sea, and some high-latitude water becomes heavy enough to sink beneath the surface layers. Our glowing parcel descends. Sunlight fades from blue to black. The familiar surface becomes a silver ceiling, then vanishes, while the pressure around the water steadily rises. This is not a single underwater waterfall, and one parcel does not follow a painted line on a map. Real circulation is messy. It swirls, mixes, splits, and sometimes waits. The conveyor belt is a useful picture, not a literal machine. Still, the broad journey is real. Newly formed deep water spreads through the North Atlantic and moves southward, far below ships, storms, and breaking waves. The sinking water carries a precious passenger, dissolved oxygen gathered near the surface. Deep currents help deliver that oxygen into dark habitats where sunlight cannot produce it. Above, another journey is moving in the opposite direction. Dead plankton, tiny shells, waste, and other organic particles drift downward. Scientists call this slow-fall marine snow. Microbes and deep-sea animals consume much of that snow. As the material is broken apart, carbon and nutrients enter the surrounding water. Our parcel becomes part of a deep reservoir, storing the chemical traces of life above. The current continues south past the equator and toward the Southern Ocean. There it meets the only ocean that circles the planet without being blocked by a continent. Around Antarctica, fierce winds, frigid air, and sea ice formation create and rearrange more dense water. Some of the coldest, heaviest water spreads along the seafloor as Antarctic bottom water, beneath other deep layers. From the Southern Ocean, deep flows connect toward the Indian and Pacific Oceans. The glowing parcel may split from its old neighbors, mix with new water, or spiral through vast basins too large to understand from the deck of a ship. Down here, speed is measured in patience. Many deep currents move only a few centimeters each second. A complete journey in the simplified global conveyor can take roughly 1,000 years, although real routes and travel times vary enormously. That means water passing a deep ocean ridge today may have last touched the atmosphere before modern cities, before many familiar borders, and perhaps before the language of this sentence existed. But the deep ocean is not a sealed basement. Turbulent mixing, seafloor shapes, and powerful Southern Ocean winds gradually lift deep water upward. In some places, wind pushes surface water aside and colder water rises to replace it. This rising motion is called upwelling. When our parcel climbs, it brings nutrients that accumulated in the darkness toward the sunlit surface. Sunlight plus nutrients can transform the sea. Microscopic phytoplankton multiply, capturing light and building living cells. From space, some blooms are large enough to tint whole regions of ocean green. Zooplankton graze on the phytoplankton. Small fish eat the zooplankton. Larger fish, seabirds, and whales join the food web. A current that spent centuries in darkness can help feed a burst of life near the surface. The returning water also rejoins the planet's heat engine. Surface currents and deep circulation redistribute heat, salt, carbon, oxygen, and nutrients between ocean basins. This motion influences climate and the conditions in which marine life can thrive. Yet no scientist would claim that every drop completes one tidy lap. The ocean contains eddies, shortcuts, dead ends, and layers that mix on different timescales. Our glowing path is an imagined guide through a connected, complicated circulation. And that complication is the wonder. The ocean remembers where its water has been. Temperature, salt, oxygen, carbon, and even tiny particles act like clues carried across generations. At last, imagine our glowing parcel reaching the surface again. Wind touches it, sunlight warms it. After centuries in the dark, it becomes part of a wave, a cloud of spray, or perhaps another current beginning another journey. The sea in front of us may look like one blue surface. Underneath, it is a moving archive that connects every ocean on Earth. So the next time a quiet wave reaches shore, remember, some of its water may have traveled farther than any human and carried 1,000 years of planetary history with it.